Afternoon, all. Just getting set up for our live session, and let's go live on TikTok as well. Let's share the screen with you in a second. And basically, today we are going to continue going over our GCSE support. And if you are able to get on YouTube, I highly recommend you do, because we are going to go over some past papers now. And for those on YouTube already, welcome. And with this, if you are a GCSE student and you're needing that support, what we're doing is a series of videos over the next couple of weeks coming up to your GCSE revision, helping you apply your information to GCSE practice. So if you can, hit the follow, because obviously we do more than just GCSE. We do a range of things, but in particular today, this is what we're going to be focusing on, especially on my YouTube live that is currently active as well. So if you're needing GCSE support, or if you know someone that does need GCSE support, get over to my YouTube channel now. And we are currently working through a past GCSE past paper. And what this means then for you all is that you get to experience this along with me as we're going through. And if you have any questions, make sure you then ask, help, and like as we're going, because it really makes the difference for me to continue supporting you all, because this is what it's all about at the end of the day, is what can I do to help you. Hey, TCT3233, hope you're doing well. Everyone, Henson misses you at school. Well, I'm hoping to come back soon to help you guys out as well. If you're able to get over to my YouTube and see what we're doing there, that'd be amazing. So with my YouTube channel that's currently live as well, I do remember you. Yes, it's Chase. Hello, Chase. Hope you're doing well. When it comes to GCSE preparation, one of the biggest things people struggle with is knowing how to apply the knowledge that they know to GCSE questions. So with GCSEs, especially coming around the corner real soon, for some of you, or in the next couple of weeks, one of the biggest things that I want to focus on is, again, applying your knowledge to the GCSE past papers. Likes in a sec, never much Henson. Got a full conversation going on. And when we are then going through this, what you're able to start to do is hopefully look at the questions that I'm showing to you and basically apply your knowledge and answer accordingly. So when we're looking at a question, for example, like this, and if again you aren't on my YouTube channel and you're wanting GCSE support or any kind of exam support, if for example you've got science questions at the end, we can by all means ask about science questions as well, because if you've got things that you're like, oh my god, I need to figure out, by all means let me know. And as we're going through this, let me know as well, because you might have questions that you go, you know what, Andy, can you let us know? I'll hopefully be in at some point soon. All right. So when we're looking at this question on our GCSE exam paper, ammonium phosphate and ammonium sulfate are made from ammonia. These compounds can be used as fertilizers. Ammonia is a alkaline solution, and we have a multi-choice question here. This multi-choice question is asking you which of the following could be used to show that ammonia solution is alkaline. Is it a conical flask, a pH meter, a pipette, or a thermometer? If you're able to answer now, that'd be amazing, and comment telling me what you think it is. So how could you tell something is a alkaline solution? Is it a Would you use a conical flask, pH meter, pipette, or thermometer? With this, then, we will move on to the next question shortly. And I'm just going to double check a few things whilst I'm moving around. So if you are wondering, it is a pH meter. Now, pH meters, the actual pH part stands for potens hydrogen. Now, what that actually means is how much hydrogen is actually available in the chemical. And so obviously if there's lots of hydrogen, we would be very acidic, and if there's lots of hydroxide, we'd be very alkaline. So when we're looking at acids and alkalis, it's exactly that. If you're joining me on TikTok right now, we are live on YouTube as well, and supporting with GCSE past papers, helping you get GCSE ready. So if you know of anyone that needs GCSE support, by all means, hop on over and let me know. Okay. So as we're then going through this paper, the next question is asking you, well, what is an advantage of using fertilizer made from ammonia rather than manure? So this is one of these kind of questions that would stump people, in the sense of what you would be looking at is the comparison. Both are fertilizers, and both fertilizers are used in an industrial situation, where then ammonia is mass produced and manure is obviously, well, I had a funny idea there, but I won't say that. But manure would be obviously harder to get, because we would be looking at how to get it on bulk, basically. And with manure, we are looking at how we can collect it, which obviously it drops here, there, and everywhere, normally from cattle. And we'd obviously have to collect all that up and then get it to the relevant farm that's needing that fertilizer, particularly. Whereas ammonia, because ammonia is mass produced, we're able to then transfer that and take that over accordingly. So when we're looking through these GCSE exam questions, this is what we're actually getting through. So the next question on our actual exam paper. So again, if you're just joining us, we're going through GCSE past papers to support you that needs GCSE support. And if you know of anyone that does, please let them know. Soldier boy, you're Andy, you're back, yay. I never left, to be fair. I've just been very busy doing other stuff. If you're needing GCSE support, obviously, let me know. And if you have any science questions, make sure you're commenting and asking as well, to what I can do to help you, because obviously I'm targeting this at I passed science. Oh, that's amazing. What grade did you get? So this next question that we're looking at is the fertilizer ammonia phosphate was made by reacting ammonia solution with dilute phosphoric acid. Grade 4. Oh, amazing. Well done. What you doing now? And was placed in a beaker. Give the name of the piece of apparatus that could be used to measure out the 25 centimeter cubed of phosphoric acid. Hey, Mitch, hope you're doing well. We're just live on YouTube as well as TikTok, going over some GCSE past papers. All right. So when it comes to this question, most people instantly will say, "Oh, measuring. Oh yeah, I'll just pour it in a beaker," and this is actually a answer that would be incorrect. When it comes to um, measurements, especially in a beaker, and let me actually grab a beaker a second. Not that drawer. Got to remember where your stuff is, ladies and gents. There we are. A whole load of glassware. What you'll notice is on the side of our beaker, it actually says approx. So where it's saying approx, that's because it's not accurate. So the actual piece of equipment we would use in a measuring situation is actually a measuring cylinder. We could also use a glass pipette or another of other things that are specifically calibrated to measure. So a glass beaker like this one is not something that we would want to use. So when we're then looking at a word equation, now I've supported many a student through this before in the past. When it comes to word equations, Heidi N. I don't know what you're writing there. You just seem to be putting up. Is it an image or something? I'm not entirely sure. With this, what we would actually then have is we have two types of equation in chemistry. We have a word equation and we have a formula equation. A word equation is literally just the words that we're looking at. And this is one of these things that I've seen time and time again where students actually struggle to understand what is actually required and what it is that they're needing for this answer. And it is a lot more simple than one would think. When we're looking at a word equation, we're just using the words used in the actual exam paper. So when we're looking at the making of ammonia, for example, we would have nitrogen plus hydrogen equals ammonia. Whereas if I was looking at the formula equation, I would have N2 plus 3 H2s equals 2NH3, which actually changes the layout of the question. So formula equation uses an equation sheet as what you would expect in using elements from the periodic table, and our equation sheet, word equation, sorry, is where we are actually using the correct language. So if you haven't already and you're needing GCSE Sport, get over to my YouTube live now because I'm streaming a past paper to support you all. So the next question is stating describe. That is our command word. So we're wanting a what is going on rather than explain, which is a why. How pure dry crystals of ammonia phosphate are obtained from the ammonium phosphate solution for 2 marks. Now, as it is a solution, we are dissolved into water. And if it is dissolved into water, um, it's quite straightforward. We look for the boiling point of our water, and which would be 100 degrees, and we would get our ammonium phosphate solution, put it in a evaporating dish, and with that evaporating dish, heat it up either above a Bunsen burner, or we would heat it up in a water bath. Now, and what I mean by water bath is we would basically get our evaporating basin, we sit it on top of our beaker, and we'd have some a little bit of water in the beaker and heat it up like so. So as then that water is actually boiling away, what you would have is the steam is at 100 degrees, which is perfect temperature for causing the water in our solution to evaporate away. Then, with that, um, we would be left with pure dry crystals. So, when we're then looking at these pure dry crystals, we are trying to then, um, first of all, we have obviously uh, evaporated the water away, and then we have been able to crystallize. So we've evaporated through heating, and we can then also they sometimes allow you to talk about the filtering first. So obviously, if we're wanting pure, you would actually look at um, filtering it first. CAC, I'm doing a YouTube live as well. Uh, Zavi, I've been very good, thank you. I'm doing a recording as well, CAC, for GCSE past papers to help those doing GCSE work. So thank you for commenting, but it is also helping those that can't attend right now. All right. I've been very good, Zavi. Thank you. I am, yeah, still supporting and doing what I can when I can. All right. The next question then that we would be moving us on to look at is the formula of ammonia sulfate is NH4 close brackets 2 SO4. Glad to hear, Andy. Your class has got me over the line in GCSE. Forever grateful. Not a problem, Zavi. Always glad to help. It was gutting that I had to stop for that period of time, but here I am back again, supporting however I can. So the question's asking you what is the empirical formula of ammonia sulfate. So the actual formula is NH4 close brackets 2 SO4. And when it comes to empirical formula, we're literally looking at the simplest way of writing the answer. So can our numbers be written in a more simplified manner? Thank you, Zavi, for the gift, and thank you, Secret Alf, as well. I know you got yes. Thank you as well, much appreciated. Remember, all the any donations are all going towards buying equipment to continue supporting local education. So if any of you are able to donate to the GoFundMe that I have running as well, we're trying to currently buy equipment to support. We are also working with Plymouth City College to start filming of practicals as well. And with that, we are using students there as well for work experience. So then they get these work experience students are then obviously getting on the job placement, and I'm then a reference for them as well. So doing whatever I can to support however I can in this scenario. Now, if I was to say about writing something in its simplest form, instead of writing NH4 close brackets to SO4, I can simplify that to N2 H8 SO4. Now, what that's actually then doing is putting it in its simplest form, its empirical level. Now, when we start to look at other questions, and again, if you are someone that's joining us that wants GCSE support, if you get over to our YouTube channel now, we're live streaming a GCSE past paper to help you get through the material and to start actually putting your knowledge to the test, if that makes sense, by literally putting your knowledge to the test. What you're actually doing is by me going through these past papers and you're having someone talk to you, it is helping. Also, what I am doing is providing tutoring with this, and if you have questions as we go, by all means ask, and I will help however I can. Now, the next question that we're actually looking at is unreactive metals are found uncombined in the Earth's crust. Now, when we're looking at unreactive metals, we can also refer to them as native metals, which are which of the following metals would you find uncombined in the Earth's crust? Is it aluminium, gold, sodium, or zinc? Now, if you can comment below and tell me what you think. So, what metal would you find uncombined in the Earth's crust? Aluminium, gold, sodium, or zinc? Let me know in the comments below. And with this, then we can start to get a greater picture of what you're thinking. So remember, when we're talking about it being uncombined, we're talking about a metal that we can literally just take straight from the earth, melt it into the mold shape that we need it, and use it instantly. So out of the four metals, aluminium, gold, sodium, and zinc, gold is found uncombined in the Earth's crust. Now, when it comes to our metals, every single metal in the periodic table can be organized in reactivity order. Now, when we're organizing it in by reactivity, what we can then understand is uh, a process called displacement. Now, displacement is where the more reactive metal is able to basically push the less reactive metal off of whatever it is combined with. So if you had a element like potassium and an element like copper, and the copper was joined with copper oxide, what would happen is the potassium coming along, being the more reactive, takes the oxygen away from the copper. Now, this is what we call displacement. Now, this is always the case. The more reactive it is, the more likely it is to take these additional compound elements off of the original element. Obviously, if the potassium already has it and the copper comes along, there is no reaction. Now we can simulate this in a number of ways. Sorry, I thought I was going to hiccup, but It weirdly stopped itself. We can simulate this in a number of ways, and we can also do the halogen reactive test as well, where we would go down the halogens and see if they will displace other elements as well. So we got metallic displacement, where the most reactive metal will always displace the lesser ones. Then we've got the halogen displacement as well. And looking at this question here, when iron oxide is heated with carbon, iron is produced. Complete the word equation for this reaction. Now, when it comes to, again, the word equation, they've given us for 2 marks already iron oxide plus carbon because they've stated that in the exam question. What then we would be looking at is the first product, which is iron. Now, if we mix carbon with oxygen, we're always going to make carbon dioxide, or if there's a limited amount of oxygen, carbon monoxide. Now, carbon monoxide is a toxic gas. Wait, via is that how you? I'm hoping that's how you say your name on here. What up, Andy? I'm all good. I hope you're well as well. Um, when we're then combining carbon with iron oxide, we're making carbon dioxide and iron. So carbon is in a lot more abundance, and because it is in so much abundance, um, we're able to displace iron, which is less reactive than carbon. And anything more reactive than carbon, well, we can't then use a furnace generally to displace it. And we would use a process called electrolysis to displace the relevant actual don't know me, but if you remember Leon Ashby from UTC, I'm now the co-owner of the team. I do remember Liam Ashby. Yes, I definitely remember him. I don't know what you mean by co-owner of the team, and obviously, I don't know if you're Liam Ashby, for example, or not, because obviously, I don't know what your name is because I'm just seeing what your company thing is. Um, if that makes any sense. I don't know what you mean by co-owner of the team. Um, so what happens to the iron oxide during the reaction? Um, does it burn, get neutralized, oxidized, or reduced? Um, so with this question, shush you. Sorry, watch is trying to join in our conversation. Um, so in this situation, um, when we are reacting and the oxygen's getting taken away, we reduce it. If something's getting given oxygen, it's being oxidized. So we always have the two. Oh, thank you, Secret Alf. Much appreciated. We always have live goal achieved. Thank you very much, everyone, for the donations. Keep them going. I really do appreciate it. The iron oxide is reduced when we take it. Therefore, the carbon is being oxidized. So, as we're then going through these questions, we're able to then start breaking down what's being asked. So, one of the biggest things that I notice with a lot of our students is the amount of information overwhelms, and rightly so. If it's overwhelming, you're going to switch off. When you have huge amounts of writing to read before the actual question, most students nowadays won't pay that attention. So my advice is always go straight to the question and don't read the information first. Therefore, you're able to then find the command word that it's asking you to do. And with finding the command word, you're able to then know what you're being. Hey, Tom, hope you're well. With looking for that command word, you are able to then know what you're being asked to do. Claim one flare. I don't know what that means. Claim. I don't know what that means. Reward. Use a flare to attract more viewers. I don't know what that actually means, but okay. If you know what that means, please comment below because I don't know what it means. So when we're looking at the command word, first of all, in the question, we're then able to start breaking these things down, and we're able to then take our information and apply our knowledge to it. So in this exam question, for those of you that are watching on my YouTube, you'll be able to see the exam questions that I'm going through. So if you're needing GCSE support or a level 2 equivalent course, if you use the Flare, TikTok shows the live to more people. Okay. Thank you very much, Secret Alf. That's much appreciated. Am I able to use what I've been given in a different video, or do I have to use it this video, is my next question for you. So, hey, Tyler, hope you're well. So this question that is on my YouTube right now is when 100 grams of copper carbonate is decomposed, so broken down, through heating, we found that the total mass of products is 100 grams. Give a reason why the mass of the copper carbonate is always the same as the mass of products formed. Now, hey, Nico, when we're actually looking at it, matter can't be created or destroyed. And because matter can't be created or destroyed, if I have 100 grams of reactants, I will always have 100 grams of products. Now, I've had students then turn to me and say, well, how can I have 100 grams of product? My balance is telling me I have 90 grams. Not all products are in a solid or a liquid state. Some of them are going to be produced as a gas, but that gas has mass. So gassy mass. With this, we would then go from there. Right, I'm going to end it there for today. I will see you again next week, ladies and gents. Have a great week. All right, bye.